guys. Really hope that you're okay and everything is fine and going on so smooth. Today's lesson is about the energy and work. How energy and work works together. What's the relation between the energy and work? In this lesson, you'll be able to compare between the kinetic and potential energy, as well as describing the different forms of the energy. There are various vocabs in this lesson, including the work, energy, kinetic energy, potential energy, and mechanical energy. Energy is the ability to do work. So actually, if you want to do anything in your life by lifting a pen, lifting a block, pushing a pen, pushing a block, this will need some types of work. So work is the transfer of energy, or it's the energy used to perform a specific task. To calculate it physically, we use a physical equation as work equals force times the distance. So in order to calculate work, you still need to find the force and the distance. Not saying that if the force and distance directions were in the same direction, this means that the work is a positive value. But if the force direction is opposite to the distance or the direction that the body covered, it would be a negative work. The measuring unit of the work is known as joule, and it equals to Newton times meter. The example for this is the lifting a box. When you lift a box, consider it as a positive work because your force is going upward and the book itself is going upward. So this is a positive work. And the vice versa, if you are lowering the book, you are trying to hold it but it's lowering down, so your force direction is up but it goes down. This is a negative work. There are a lot of forms of energy. Keeping in mind that the first three are the three main types of energy: the kinetic, potential, and mechanical. While the other are forms of energy like the thermal, chemical, electrical, sound, light, and nuclear energy. We start with the kinetic energy, and it's always the meaning of the word kinetic means in motion. So whenever you are moving, there's a type of energy getting out of your body. So the energy released due to the motion is known as the kinetic energy, and it depends on two things: the mass and the speed of the object. Simply, if the mass increases or the speed increases, the kinetic energy value will increase, and if the mass increases, also the kinetic energy will increase. The potential is the second type of the energy, and it's the energy of an object due to its position. There should be, the word position means there should be a distance from the land or water surface. This is a man standing in this height above the sea level. So as long as there is a height, there is a big value for the potential energy. But if there is no height, so the potential energy value will be zero. And it mostly depends on the weight and height. If we talk about the mechanical energy, we can simply say that the mechanical is the sum of both kinetic and potential energy. And in order to calculate it, you're simply going to have to know the kinetic and add it to the potential energy and put the value in joules, measuring unit. Now I'll talk about the thermal energy. As we discussed before, the particles of matter are in a continuous motion. But if you heat up those particles, those motions and collisions would increase. So increasing the energy will increase the kinetic energy of the particles itself. This is known as the thermal energy. There's another type which is the chemical energy. Even during, if you eat, there's a chemical energy released. The electrical one, we use it every day, every single day. We're using the electric energy, whether to watch TV, to listen to music, turn on the mobile, switching off the mobile, turning on the light or not. Those are all type of an electrical energy, and it's due to the flow of the electrons. Sound energy, it's the same thing. It's an energy caused by the vibration of the object or the vibrating of the object. So there should be vibration, otherwise you won't be able to hear. Light energy, also produced by the vibrating of the charge or the electrical charge inside the lamp, because inside the lamp it consists of 2 or 3 elements, copper and lead. Both of them are consists of parts or particles, and those particles is being moved and reducing or producing the light energy. The end, or not the final, the nuclear energy, and this is found in each and single type of atom, because atom is made up of nucleus that itself is consisting of proton and neutron and electrons. Those subatomic particles are controlled, and there's an energy controlling them or getting out of them. This is the nuclear energy. Energy form examples for the potential energy and the kinetic energy, and this is very important, by the way. The forms of potential energy in here, like the chemical energy that links between the atoms and molecules, as we discussed recently. The nuclear energy stored in the nucleus of an atom due to the link between the protons and the neutrons. Third one is the magnetic energy. It's also considered a form of potential energy, only in case of the reverse pool, north and south pool together, because they will attract and they will stop moving. Stop moving means potential or stored. The last one is the electrical energy, when the particles of different charges attracts to each other. Let's go have a look to the forms of the kinetic energy. Kinetic energy, like heat that resulted from the vibration of matter particles, as I showed you before in the previous slide, whether it's a solid or a liquid or even a gas. Electricity is a form of kinetic energy due to the motion of the electrons inside a contactor. So there are objects moving, like the electrons, and each electron has a mass. If you're just going to know the mass and the velocity, you will simply calculate the kinetic energy of the electrons. Sound energy results from the transfer of energy in the form of waves. Without the waves, we will not be able to hear the sound. The light energy itself also is being transmitted by a wave motion. So the word motion concludes the kinetic, the word stored concludes the potential. We can simply say that the energy can change from one type to another type without losing or gaining in its value. Like, I cannot use 20 joules of energy and change those 20 joules from one form to another, and I'll find the value like 18 joules. Where the hell is the 2 joules has gone? So there is no meaning. The energy cannot be destroyed, neither created nor destroyed. It only changes from one form to another, and this is globally known as the law of conservation of energy. So whenever energy is used to do work, that energy only changed, but it never changed the value, changed the forms. Hope that this fulfilled the needs for this lesson. Thank you very much for watching, and have a good day.